Welcome to NICE Real-Time Designer how-to videos. In this video, we will show you how to use simulated objects for grid control in the Real-Time Designer. Grid control is one of the available objects that can be simulated using Real-Time Designer. Generally, using the simulated objects allow us to capture objects from an application that is not recognized by Real-Time Designer connectors. It gives the Real-Time Designer the capability to see the application using visual elements only. To use simulated objects, the ABBYY Fine Reader engine must be installed and ran in the background. You can confirm that by observing the process in the Task Manager. We will start by capturing an application. To do this, click the Capture button when at the Simulated Objects tab. The Real-Time Designer will be minimized automatically, what will allow you to select the entire application by clicking with the target cursor inside its window. To fine-tune the areas in the capture frame, we need to calibrate a frame. Right-click the frame and select Calibrate. Use the sliders to adjust the focus in the frame until you can clearly access the areas you want. Click OK to complete the calibration. Now we need to make the application's contents to be identified on a live screen. To make this, we need to define the anchor, unique fixed object in the frame such as an image or title. In the Objects ribbon, click the Set Anchor button and then click the frame's title. In the Properties pane on the right, we can update the name and any other properties as needed. For more accurate work, we will set the new names to the frame and the anchor. Rename the frame, then click the anchor in the frame's tree and update its name in the Properties pane. Next, we need to define the controls for the simulated object, in our case, the grid. On the Objects ribbon, click Set Controls, then click Owner Drawn and select the grid's area. In the Properties pane on the right, update the control's name and select the correct control type. Then, click Test to open a window and show the grid as it is validated. Click Test Recognition to see if the control's elements identified properly. The headers must be framed in blue and the cells in red. As you can see, the left column cells defined as content cells and not as headers. To change it, sign the checkbox next to Has Header Column Property and click Test Recognition again. As you can see, now the head cell in each row framed in blue. In addition, it is necessary to define the behavior of the grid on user selection. Open the Selection Mode dropdown. Select Cell and test the recognition once again. You can see that the selected cell framed in green. That means that the selection mode was changed properly. Click the Save and Close button. There are several functions and events are available for simulated grid controls. Next, we are going to create some of these functions to demonstrate how the grid can be controlled remotely. Go to the Business Entities tab to start the process. Click Types in the left pane. Then click New Type in the Business Entities ribbon. Set a new name for the created type and click the New Property button to add a property to a type, then give it a name. Since the property type that defined by default is text, we are not going to change it. Perform these steps once again to add the second property. When it is done, right-click on the type and select Create the instance of grid. Right-click again and select Create a list of grids. Now we are going to add another type which will include the appropriate functions to handle the grid. Create a new type and set its name to Grid Data. First, we need to create a function that will activate the simulated grid control. This function will include three actions: language determination, activation, and bringing the application to the front so that it will be recognizable. Click the new function and give it an appropriate name. Open Insert Instruction dropdown and select Function Invocation. Click Select Function, select Frames, click OCR Languages, and sign the checkbox next to the appropriate language. Select the function invocation again and click Select Function, select Frames, Simple Grid, and click Activate. To create the function that will bring the grid to the front, perform the previous steps. Selecting Bring to Front instead of Activate. Next, we will create a function for the grid deactivation. The actions required for creating deactivation function are the same as for activation, but the final selection should be deactivate. We also need to create two counters, which will help us to determine the number of rows and columns in the table and return the values from the grid cells. Add two properties to a grid data, give them appropriate names, and set their type as number. Now we need to create the function that will use previously created counters to return the number of rows and columns. Create a new function and give it a name. Open the Insert Instruction dropdown and select Assignment. Click Select Object and choose the column counter you have created previously. Next, click Enter Value. Select Frames, Simple Grid, Controls, click DGV, the name we gave to a grid control, and select Get Columns Count. Repeat these steps, selecting the rows counter as an object and Get Rows Count as an assigned value. In order to set the new values inside the grid, there are three additional variables should be created. Two number type variables, row number and column number, for defining the cell location inside the grid, and one text type variable for setting a new value inside this cell. Now, we need to create a new function that will retrieve the cell's values from the grid. Create a new function and give it a name. The first action will be clearing the entire data related to a grid we have created at the beginning. Open Insert Instruction dropdown and select Function Invocation. Click Select Function. Select Business Entities, List of Grids, Remove All. Next, we need to create a loop that will pass over each row and retrieve the cell entries. Open Insert Instruction dropdown and select For. Give a name to the iterator, defining the start value as 1. Set the loop condition so that the iterator is not larger than a variable we have created for counting the grid rows, and define the loop increasing value as 1. Now we need an assignment to create an instance of a grid. Open the Insert Instruction dropdown and select Assignment. Click Select Object, go to the Business Entities and select Grid. Then click Enter Value, go to Library Objects and select Create. The next action will be to assign the fields to the created grid instance. Add another assignment and set Field 1 as an object. Set Trim function as an assigned value to ensure that all the captured spaces within text values will be eliminated. Click Select Text to define the text field on the frame. Then go to Frames, Simple Grid, Controls, DGV, and select Get Cell Text. It's also necessary to add the index reference of it, so click Select Row and select the iterator name. Then click Select Column and set the value to 1. For the second column, we need to perform the previous steps once again, setting the column value to 2. The final action is adding the grid to the list. To do this, add the Add Item function and select the grid as a business entity to be added. When it is done, right-click on the grid data and select Create an instance of grid data, so we can use it in a callout or any other places. We have done creating all necessary variables and functions. Now we are going to put them logically on the callout. Go to the Presentation tab. Create the new callout by clicking the New Blank Callout button on the Callouts ribbon and give it a proper name. Click on the gear icon on the Links and Data ribbon to add a first action. Give it a name and select the activation function that we created. Add the second action and select the function for counting the rows and columns. To see the counting results, we can add the dynamic text field linked to an appropriate variable. Add the third action and select the function for retrieving the grid values. To see the data retrieved, we can add Simple To on To table and assign the grid list to it. The next action for updating the table will not use any created function, but only the variables. Create 4 on To table and fill the top row with relevant headers: column, row, value, and action. Down the column header, add Input text box and connect it with the variable defining the column number in the grid. Perform the same actions with the row and the value using the appropriate variables. Down the action, add the button and set its name. Make the button fire the cell set text function on click using the correct variables. The last action is a grid deactivation. To add this action, we need to perform the same steps as for the first action, selecting the deactivate function at the end. The callout is ready. For a quick use of it, we need to create a quick callout. Open the Project tab, go to the Quick Callouts and click the Quick inside the tree. From the drop-down, select the callout we have created. To complete the process, save the project. Now we can run the project to test if everything works properly. As you can see, all the actions work properly. The rows and columns are counted correctly, the entire data is retrieved, and the cell value changes accordingly to update. Here is a quick summary of what we reviewed in this lesson. Thank you for watching and stay tuned for more short how-to videos on the NICE Real-Time Designers functions.